I want you to do something for a second. Just look around the room you are sitting in right now.
Yeah, just take a quick look.
Right. Look at your laptop or your coffee mug, maybe the chair you're sitting on, or the shoes by the door. Almost every single physical object you can see around you likely spent a significant amount of time sitting inside a corrugated steel shipping container.
It really is the invisible conveyor belt of the modern world.
Oh,
We
absolutely.
completely take it for granted until, like, a supply chain snarl makes the news, but that network is always running in the background.
But here is the staggering, unseen logistical challenge we are looking at today. What does it take to move all of those millions of steel containers across the globe without, completely destroying the planet in the process?
Right, because historically, shipping and heavy infrastructure have been incredibly carbon-intensive industries.
Just massive footprints.
Yeah, and they are notoriously difficult to decarbonize. But the source material we are diving into today outlines a surprisingly aggressive counter-narrative.
I was shocked reading through it.
I mean, we are looking at a stack of internal strategies, corporate presentations from 2024, and sustainability reports from APM terminals.
And just for context, APM Terminals is a colossal port operating company. They're a subsidiary of the Maersk Group. We're talking about a true titan of global trade here.
Oh, massive.
So the mission of this deep dive is to extract the blueprint for how a legacy, heavy infrastructure company plans to achieve net zero emissions a full decade ahead of the industry standard.
Which is wild.
Right. We want to know how they plan to pull this off mechanically and what it means for the future of global supply chains. So, okay, let's unpack this. Because before we can even talk about zeroing out emissions, we have to grasp the sheer scale of the footprint we are talking about.
Well, and the scale is really the primary friction point here. I mean, if you don't understand the physical size of the operation, you just can't appreciate the engineering difficulty of the decarbonization effort.
Right, it's not just swapping out a few light bulbs.
Exactly. According to their 2024 corporate figures, APM Terminals operates in 33 different countries. Yeah, they run 60 key port and terminal facilities across the globe, from the Americas to Europe, Asia, the Middle East, and Africa.
And the human and financial volume is just immense, too. We're looking at around 33,000 employees.
It's a small city.
It is. And in 2024 alone, they generated $4.5 billion in revenue. But the metric that really caught my eye is the physical movement. They are orchestrating an estimated 23.2 million container moves in 2024.
Yeah, and let's define what a move actually entails, because it's not just, a ship sailing across the ocean.
Right.
It's the complex choreography right at the port. A single move involves a towering gantry crane lifting a multi-ton steel box off a cargo ship.
Just massive machines.
Right, and lowering it precisely onto a terminal tractor, driving it across a vast asphalt yard, and then using another piece of heavy machinery to stack it before eventually connecting it to an outbound freight train or a semi-truck.
It's an entire ballet.
Exactly. Their core operational vision is literally defined as lift, store, and connect.
Lift, store, and connect. I mean, it sounds simple until you realize you're executing that sequence 23 million times a year with machinery the size of office buildings.
I'm doing it fast.
Right. Trying to decarbonize an operation of this magnitude is like trying to rebuild the engine of a cargo plane while it's in midair.
That's a great way to put it.
Because you can't just pause global trade to upgrade the hardware.
Yeah.
People still need their medicine, their food, their electronics.
You absolutely cannot stop the conveyor belt. So the foundational strategy they're using to make this mid-air engine rebuild possible is something they refer to in their internal documents as the lean way of working.
Okay, I saw that.
Yeah, and it was introduced across their terminals back in 2018.
I always hear the term lean, and I immediately think of, tech startups or maybe automotive manufacturing.
Sure, Toyota and all that.
Yeah, right. But looking at how they apply it to a global shipping port, it seems like they've essentially hacked the methodology. If lean is ultimately about eliminating waste and transloading every action into customer value, APM has simply redefined what waste means in a physical space.
That's exactly it. They have taken an operational efficiency framework and just turned it into a climate action framework.
Which is brilliant.
It really is. In the traditional sense, waste is just lost time or lost money. But under this adapted lean methodology, carbon emissions and truck idling times are treated as the ultimate operational defects.
They're literally flaws in the system.
Right. They are physical manifestations of waste that just must be eradicated from the process.
So a truck sitting in a mile-long line at a terminal gate with its diesel engine rumbling It isn't just a traffic annoyance anymore. Under this framework, that idling truck is a failure of the process.
Exactly. It's generating carbon waste because the choreography failed. And every drop of fuel saved through better logistics directly serves the decarbonization target. And it forces terminal managers to look at the yard completely differently. You aren't just managing steel boxes anymore.
Right, what are you managing?
You are managing the microscopic flow of energy required to move those boxes.
Okay, let's talk about the hard targets then, because redefining waste is only useful if it actually leads to real reductions. From the sources, it seems like they are basically moving the goalpost closer to themselves on purpose.
Oh, they definitely are. The overarching commitment from APM terminals is to achieve net zero greenhouse gas emissions by 2040.
2040.
Yes, and to put that in perspective, that is a full 10 years ahead of their original 2050 ambition. And it significantly outpaces the general maritime and logistics industry standard.
And the sources note this is aligned with the Science-Based Targets Initiative, or SBTI specifically, their 1.5 degrees Celsius pathway.
Yeah, the SBTI 1.5 degree pathway is essentially the gold standard for corporate climate pledges right now.
It's the one you want to hit.
Exactly. It requires companies to set targets that align with the latest climate science to prevent the worst impacts of global warming. It's not just a vague pledge to do better.
Right, no greenwashing.
No, it requires mathematical proof of reduction. And this ties into the Maersk Group's broader aim of delivering 5 million tons of CO2 savings per year by 2030.
5 million tons a year. That is a staggering volume of gas to remove from an industrial process.
It's massive.
But to get to net zero by 2040, I mean, they can't just wait until 2039 and flip a switch. The crucial interim milestone here is 2030. By that year, APM Terminals is committed to a 65% reduction in their Scope 1 and Scope 2 emissions compared to a 2022 baseline.
And whenever we see Scope 1 and Scope 2 in these corporate reports, it is really helpful to establish the boundaries.
Yeah, let's break that down.
So Scope 1 is the physical exhaust coming directly out of the tailpipes and chimneys of the company's own equipment. It's the diesel burned by the tractors driving around the port.
Okay, that makes sense.
And then Scope 2 represents the indirect emissions from the generation of the electricity the company purchases. So the power plant down the road that generates the electricity to keep the terminal lights on.
Got it. So to slash those Scope 1 and Scope 2 emissions by 65% in just a few years, they have to attack the problem from multiple angles simultaneously.
They do.
And the first logical step, tying right back to that lean methodology, is energy consumption optimization. You have to stop bleeding energy before you can transition the energy source.
Exactly. Optimization is really about doing more with less. A prime example from their strategy is the implementation of automated gate technologies and digital truck appointment systems.
Which makes complete sense when you think about the physics of a heavy semi-truck. I mean, a fully loaded truck requires a vast amount of diesel just to accelerate from a dead stop.
Oh, a ton.
If you have a chaotic port where trucks just show up and wait in line, stopping and starting every 20 feet, you are burning fuel for absolutely zero economic gain.
It's pure waste. By using digital solutions to essentially create an air traffic control system for the asphalt, they can choreograph exactly when a truck arrives to pick up or drop off a container.
So no more lines.
Right. The truck rolls in, does its job, and rolls out. Less waiting means drastically less idling, which instantly cuts Scope 1 emissions without replacing a single vehicle.
That's huge. But eventually you do have to replace the vehicle,
You do.
which leads to the second major push.
Yeah.
Equipment electrification. They are transitioning their fleet of container handling equipment, which they call CHE, from diesel engines to battery electric systems. But let me push back on the logistics of this for a second.
Correct.
Wait, if you take a heavy-duty terminal tractor, rip out the diesel engine, and replace it with a massive battery, you're plugging it into a local power grid. If that local grid is still burning coal or natural gas, aren't you just moving the emissions from the tailpipe to the power plant?
Yes.
You're essentially just shifting the problem from Scope 1 to Scope 2, right?
It's a great point, and this is the exact trap that many well-intentioned companies fall into. Electrification is really only as clean as the grid it plugs into.
Right.
But APM Terminals addresses this vulnerability through a dedicated transition to renewable energy and green fuels. They know they can't passively rely on local municipalities to clean up the power grid fast enough.
They'd be waiting decades.
Exactly. So they have to actively procure and generate their own clean energy.
And how are they managing that procurement across 33 different countries with vastly different infrastructure
Well,
capabilities.
they utilize mechanisms like green power purchase agreements, or PPAs.
Okay.
These are long-term, legally binding contracts to buy electricity generated exclusively from renewable sources, which often actually funds the construction of new wind or solar
Oh,
farms.
that's smart.
But they are also building on-site generation. Look at their terminal in Barcelona, Spain. They recently installed expansive solar arrays directly on the facility, which are projected to provide 5.12% of the entire terminal's energy needs.
Wow. Generating over 5% of a highly industrialized port's power from the sun hitting its own rooftops. That is a solid engineering feat.
It really is.
But I still see a physical friction point with the batteries themselves. Batteries are incredibly heavy. If you load up a terminal tractor with a giant lithium-ion battery, doesn't that extra weight just chew up the asphalt in the yard faster, creating like a new maintenance nightmare?
It absolutely does. The weight of battery electric machinery is a genuine structural challenge. These terminal surfaces take a beating.
I can imagine.
It means the engineering of the port itself, like the thickness of the concrete, the layout of the charging stations, it has to evolve alongside the vehicles. A PowerPoint strategy is easy to make green, but the physical transition is incredibly disruptive.
Which is why I want to dig into the global case studies in these sources. We really need to see how this friction is being managed on the ground.
Yeah, let's look at a few.
Let's look at Mobile, Alabama.
Oh.
According to the 2024 data, the mobile terminal already successfully reduced its Scope 1 and Scope 2 emissions by 8% in 2023.
That's a great start.
And since February of 2024, the entire facility has been running on 100% renewable electricity.
Mobile is also a prime example of tackling a completely different source of emissions, which is the ships themselves. They are implementing a technology called shore power.
The mechanics of shore power are fascinating to me. When a colossal cargo vessel docks at a port, it historically leaves its massive auxiliary diesel engines running just to keep the ship's lights, computers, and refrigeration systems online.
Right, because the crew is still living on board.
Exactly. And that dumps a localized cloud of pollution directly into the surrounding coastal community. But with shore power, they literally plug the ship into the port's electrical grid.
Yeah, it basically functions like plugging an RV into a hookup at a campsite, but on a vast industrial scale.
That's a great analogy.
You can shut down the ship's engines entirely while it's being unloaded. It dramatically improves local air quality. And alongside that, Mobil is bringing in 10 fully electric terminal tractors in October of 2024, complete with all the necessary charging infrastructure.
That's amazing. But retrofitting an old port like Mobile while it is still running at full capacity is incredibly difficult. But looking at the sources, it seems like they have a totally different luxury in Croatia. They basically get to cheat the mid-air rebirth problem by just building a new plane.
Yeah, Croatia is a unique case. It's a completely new terminal currently in development, set to go live in 2025.
So no ripping up old concrete.
Exactly. Instead of tearing up old asphalt to lay electrical conduit, they get to build the port of the future from scratch. The Rijeka Gateway is being designed to be the most advanced terminal in the Adriatic region.
Wow.
It will be fully electrified from day one. It'll heavily utilize remote operations, where crane operators actually sit in control rooms rather than up in the cabs, and its power supply will be entirely secured by renewable electricity.
Building it right the first time removes so much of that legacy friction. I also noticed 2 other locations doing really innovative work that pushes beyond their own borders. Kalundborg, Denmark, is winning sustainability awards, not just for cutting their own footprint, but for helping their customers cut their Scope 3 emissions.
Oh, we should definitely define Scope 3 here, because it is notoriously the hardest category of emissions to track and control.
Yeah, what does that actually mean?
Scope 3 covers all the indirect emissions that occur up and down a company's value chain. So, for a retail brand selling shoes, their Scope 3 emissions include the pollution from the cargo ships and freight trains transporting those shoes.
Vehicles the retail brand doesn't actually own.
Exactly.
So how does a port in Denmark help a shoe company cut its Scope 3 emissions?
By offering a fundamentally greener logistics node. If a port operates on renewable energy, utilizes electric fractors, and provides efficient rail connections, any cargo routed through that specific port automatically incurs a lower carbon penalty.
Oh, I see.
Yeah, the port's Scope 1 and 2 reductions become their customers' Scope 3 reductions.
That interconnectedness is wild. And then there's Pipavav, India, where they are partnering to build a 100% green hydrogen ecosystem. They are handling the production, storage, and transport of green hydrogen right at the port. But wait, Hydrogen is notoriously volatile.
Very.
How do you safely store a highly flammable gas at a bustling commercial port?
Well, the logistics of a green hydrogen ecosystem are intense. It requires specialized infrastructure. We're talking pressurized storage tanks, dedicated pipelines, and blast-proof containment zones.
That sounds expensive.
It is. Producing it on-site usually involves using renewable electricity to power electrolyzers that split water into hydrogen and oxygen. By co-locating this production right at the port, they create a clean fuel hub for heavy transport like long-haul trucks or even future cargo ships.
If they don't have to transport it.
Exactly, without having to transport the volatile gas over long distances first.
Okay, but reading through all of these case studies, electric tractors, solar grids, green hydrogen facilities, ripping up concrete to lay charging cables, I keep coming back to the brutal reality of cost.
Yeah, the price tag.
Swapping out highly specialized heavy machinery is unimaginably expensive. You can't just go to a commercial dealership and buy a fleet of electric terminal tractors on a discount.
No, you can't. And the market dynamics for this equipment are a major bottleneck. But the transition relies on a fascinating industry maneuver that is detailed in the sources. In 2023, APM Terminals co-founded an initiative called ZEPA, the Zero Emission Port Alliance.
Yeah, I was reading the ZPAL Alliance section, and I had to do a double take. They didn't team up with some eco-charity or a tech incubator. They literally partnered with DP World, their biggest direct competitor.
Yes. Two of the most fierce rivals in global logistics just decided an ally. Because they looked at the engineering math and realized they absolutely cannot survive the transition alone, the current market for battery electric container handling equipment is just too fragmented. Every manufacturer uses different battery chemistries, different charging plugs, different software.
It's like the early days of cell phone chargers.
Exactly. And because it's fragmented, it's incredibly expensive to produce. By forming ZEPA, these giants are allying to standardize the specifications for battery electric equipment across the industry.
So it's not even about playing nice for the environment. It's a brute force economic strategy.
Exactly.
If everyone agrees to use the exact same standard batteries and charging interfaces, the manufacturers can finally scale up production lines, which drives the per unit cost down.
Spot on. The stated mission of ZEPA is to create economies of scale so that green battery electric equipment becomes economically superior to traditional diesel equipment within the next 2 to 8 years.
Wow, 2 to 8 years.
Yeah, they are using their combined monopoly power to force the manufacturing market to evolve faster than it naturally would.
It's about manipulating the economics of the entire industry so that doing the green thing eventually becomes the cheapest thing.
Precisely.
But here's where the strategy pivots from machinery to survival. The sustainability report places a heavy emphasis on the physical environment and the human element. Decarbonizing infrastructure isn't just a PR exercise for these companies. It's a matter of literal operational survival against a changing climate.
And the physical climate risks to port infrastructure are severe and compounding. I mean, by definition, ports are located right on the coast, making them highly vulnerable to extreme weather events, storm surges, and sea level rise.
The climate modeling in the sources is sobering. They specifically call out the South Florida Container Terminal in Miami, which faces a 100% risk of hurricanes.
100%.
And the Guangzhou South China Ocean Gate Terminal faces severe threats from both massive floods and cyclones. It creates a bizarre paradox, you know. You are spending hundreds of millions of dollars to build state-of-the-art green infrastructure in geographic zones that are simultaneously at the highest risk of being washed away.
When your entire business model relies on heavy machinery sitting precisely at sea level, extreme weather is an existential threat. This necessitates intensive on-site resilience planning.
What does that look like?
Well, they are elevating critical electrical infrastructure, reinforcing seawalls, and designing drainage systems that can handle unprecedented downpours. They aren't just trying to mitigate future climate change, they are desperately engineering for the impacts that are already locked in.
Because you can't have a sustainable port if the physical port is underwater. And crucially, you also can't have a sustainable port if you don't build a safe, sustainable culture for the 33,000 human beings operating those machines.
And this brings us to the S&G in ESG, social responsibility and corporate governance. The report details strict human capital goals that run parallel to their climate targets. For instance, APM Terminals is aiming for 40% female representation in their leadership ranks by 2025.
Which, in a traditionally gritty, male-dominated heavy logistics industry, 40% is a very aggressive target.
Highly aggressive.
They also highlight a strict zero-tolerance policy for harassment and a major push to ensure that outsourced third-party workers are guaranteed the exact same health, safety, and working hour protections as direct employees. Because you can't offshore your human rights responsibilities just because someone wears a different contractor badge.
Absolutely. And perhaps the most complex social challenge they are tackling in these reports is responsible ship recycling.
The end of the line for the massive cargo ships themselves.
Right. When a colossal steel cargo vessel reaches the end of its operational life, it has to be dismantled. Historically, this happens in places where labor is incredibly cheap and safety regulations are virtually non-existent.
It's pretty bleak.
It is. Ships are often just beached on the sand, where workers tear them apart by hand, leading to horrific injuries and allowing toxic heavy metals and oil to leak directly into the local ecosystem.
But the sources outline how APM Terminals is pushing for transparency and structural safety in places like Alan, India. They are demanding that facilities use impermeable concrete floors with proper drainage systems to catch toxins, rather than just cutting steel on the open beach.
Yes. They are actively providing safety training, protective gear, and medical care for the workers who dismantle these old ships. And from an engineering standpoint, they are exploring the mechanics of a closed-loop system.
What's that involve?
Well, how do you take the millions of tons of scrap steel from a dismantled ship, melt it down in electric arc furnaces powered by renewable energy, and feed it right back into the global supply chain to build new green infrastructure?
It reveals a core deduction running through all these sources.
Yeah.
True sustainability has to be holistic. You cannot separate the physical hardware from the human software.
Exactly.
The hardware is the electric cranes, the solar panels, and the standardized battery plugs. But the software is human capital, safety culture, and supply chain ethics. If you neglect the human software, the green hardware will eventually fail.
It is a monumental, multifaceted task. I mean, they have to manage the economics, the physics, and the sociology of global trade all at once. They are rebuilding the airplane midair, but the blueprint is clearly laid out and mathematically rigorous.
So what does this all mean for you listening right now? The next time a package arrives at your front door, I want you to take a second and consider the incredibly complex, highly choreographed, and rapidly greening global network that brought it there.
It's a miracle it works at all.
Truly. The story of APM Terminals proves that even the heaviest, most traditional carbon-intensive industries on Earth can aggressively pivot to a cleaner future. It requires applying that lean methodology to hunt down waste, forcing cross-industry cooperation even with your fiercest rivals, and treating human safety and climate resilience as the ultimate baseline for success.
The transition from analog fossil fuel logistics to a digitized electrified network is fully underway. It is no longer theoretical.
I want to leave you with a final thought to mull over. Historically, the world's great port cities, places like Rotterdam, New York, Singapore, their entire cultures, economies, and local identities grew up around the heavy noise, the diesel smog, and the vast, gritty manual labor forces required by the shipping industry. But as these ports become perfectly efficient, totally quiet, highly automated, and run on closed-loop renewable energy systems, how will that fundamentally alter the culture, the economy, and the very soul of the port cities of the future? Think about that the next time you pick up your coffee mug and imagine the quiet green journey it will take tomorrow.